Consider the expression 1 plus x squared up to x to the power n minus 1. And suppose you know that x is greater than 1 and n is also greater than 1. This is given information. Additionally, you know that this number 1 plus x squared up to x to the power n minus 1, after you compute it and add it up, this number is a prime number. This p is prime. This is also given. Can you show that n is also prime? So given that this sum is prime, given that x is greater than 1, n is greater than 1, can you show that n, this number, this exponent here, is also a prime number? This problem is from ISI BStat BMath entrance, but it also came in Russian Math Olympiad. So how do you go about this? The first idea is to assume that it's a proof by contradiction. So assume n is not a prime. In fact, assume that n is equal to a times b, because if it's not a prime, then it can be written as a product of two numbers. It can be written as a product of many numbers probably, but at least two numbers. And a is not equal to n or 1, b is not equal to n or 1. So for example, if n is 6, then a could be 2, b could be 3. Of course, if n is 6, we cannot take a as 6 as b as 1, or b as 6 as a as 1. We want we want to use the property that n is composite. So assuming that n is not a prime, can we reach a contradiction? So get a contradiction. What does it mean? Well, maybe what we can do is that assuming n is not a prime, we can take this expression. Let's say here it is x to the power 5 if n is 6. This is just an example. Maybe we can show that this quantity here, this quantity is not a prime. That would be a contradiction because initially we assumed it's a prime. So if we now show that it is not a prime, then we will be done. So what is the strategy? Strategy is step 1. Assume n is not a prime. In fact, assume it's a product of two numbers like a and b. And step 2, show that 1 plus x squared up to x to the power n minus 1 is also not a prime. And then this leads to a contradiction. So obtain a contradiction. This is the idea. Now, link in the description will take you to the complete discussion of this and associated notes and materials. But try this problem on your own, and maybe you will be able to solve it on your own. All right, I'll see you in the next video. Take care.